A lot of charlatans manage to fool a lot of people by deliberately misusing the words work and energy and trying to treat them as if they were being used in their proper scientific context. Also, a lot of people who are better meaning than that will make the same sort of mistake and end up with some very surprising results that often convince them that they've done things like create some sort of an infinite source of energy or something like that. So let's try to dodge those issues by making sure that we're rigorous and well informed about our definitions for both. So energy is going to be our ability to do work. Whether it's our ability or the ability of some sort of a reaction or any other sort of system, energy is our capacity to do work. So let's get specific about what work means. Work is the force needed to move an object a certain distance, and it's got to be against some sort of a force, like gravity. If there's no force to push against, you're not doing any work. Now, let's take a look at the equation for that for a second. It's work equals force times distance. If we expand out force a little bit, we have mass times acceleration. So work equals mass times acceleration times distance. But notice, if we were to think about what those units are going to be, mass is probably going to be either grams or kilograms. Acceleration is in meters per second squared. Remember, the seconds is on the bottom of the fraction, so is the square. And the square is not applying to the meter. And then the distance is going to be measured in meters. So if we were to compact all those together to create a single unit, we're going to have kilograms on top. We're going to have meters times meters on the top. And we're going to have seconds squared on the bottom. That's going to be the format that we're going to see for whenever we're talking about work. So you can see that we're going to compact it even further. We'll have kilograms times meters squared divided by seconds squared. And that's exactly the form that we're going to use. Now this is for all types of energy and includes work. The thing is, we'd be writing this so often whenever we talked about energy, we'd definitely get a wrist cramp pretty quickly. So instead, we're going to compact that into a super unit that contains all of that within it, and it's going to be called the joule. This is going to be our standard unit whenever we're talking about energies, whether it's energy in general, whether it's work, or whether it's other kinds of energy that we'll learn about later in thermochemistry. Now, the joule tends to be a pretty small unit of energy, surprisingly enough. Even though you're lifting an entire kilogram, 1 meter, against the force of gravity, with that amount of energy, it's still kind of a small number. So usually we're going to be talking about 1,000 joules, kilojoules. So be aware of that. We're going to be seeing this metric prefix quite a bit when we talk about energy. Now, that said, when you pick up anything to eat, you see on the label, at least here in the US, you're going to see calories listed as the food content, energy content. In other countries, you also see joules. Sometimes you'll only see joules, kilojoules. But at best, you're going to see both of them, and often you're going to see calories. So even though it's not an SI unit, we're going to run into it very often, especially those of you who are not pursuing pure chemistry and are instead in some sort of a biology or a health professions kind of direction. Now, the calorie equals exactly 4.184 joules. And it's exact, so there's no impact on your significant figures when you do that conversion factor. So you can think of both these as having infinite sig figs. 1.000000 equals 4.184000000. But people in food science got so used to writing calorie that they just decided to kind of rescale things by capitalizing it. So a capitalized calorie is actually going to be 1,000 lowercase calories. Oh, my pen didn't like me right there. There we are. So when you see a capitalized calorie, when we're describing foods and things, remember that that's going to be 1,000 calories, which equals 1 kilocalorie. Make sure that you're handling that unit correctly, or better yet, use the joule.